It's a few minutes to 1, so we're going to get started. I trust everybody is in the room that needs to be in the room. And we will, I just want to welcome everybody. This webinar is sponsored by, and brought to you by Sawmilling South Africa and the DTIC in partnership with the University of Stellenbosch. We have some amazing speakers today, and I'm really excited for this session. We are using AirMeet for the first time. So firstly, apologies for any technical hiccups that you may have experienced trying to get into the room. My nerves are absolutely shattered using a new technology. So we're just trying to, we'll feel our way around today and just hold thumbs, please. So wood is a wonder material. It's a material that has been with us since the earth was formed. It's our past, it's our present, it's also in our future. And wood is cool. Wood is also warm. It makes us feel better. It makes us feel better in forests, in log cabins, around the table with friends and family. And wood is versatile. You look around wherever you are, it's furniture, it's pencils, it's paper, it's pallets, it's dissolving wood pulp, it's cellulose, it's boxes, and it's buildings. Wood is art, and wood is architecture. Wood is all around us, and wood is what we are going to be talking about today. So I'm really excited to introduce I'll introduce our first two speakers shortly, but just some housekeeping notes. There are some questions. There's a question and answer box on the right-hand side. You'll be able to post your questions in that session, in that little box. There's also a chat functionality, and you should hopefully have seen the poll that I published a short while ago so that you were able to answer that. But if you know of anyone who wasn't able to register, we do have a live stream on our YouTube channel, on the Sawmilling South Africa YouTube channel. But so we'll kick off with Brand Wessels. Professor Brand Wessels is from the University of Stellenbosch. He is going to be introducing our speakers today. Brand and then Bram de Villiers as well. He'll be handling our Q&A session a bit later. And both of these gents are lovers of wood. And they love wood, and it's exciting to see so many people actually enjoying the potential of wood. I was part of the World Forestry Congress virtually, just watching some of the sessions, and it's so exciting to see the potential of wood in our society, in our economy, and for our environment. So over to you, Brand.
Good afternoon, everyone. So our first speaker will be Jamie Smiley. Jamie is the Managing Director of XLAM. They are, of course, the first cross-laminated timber manufacturer in South Africa. They're also now doing glue-laminated beams. Jamie and his team offer design and manufacturing services at a range of levels. And the title of Jamie's talk will be Local Capacity for CLT and Engineered Wood. And then our second speaker will be Michael Kluis. Michael is a structural engineer at Box Up Possibilities. Michael focuses on designing with timber as well as other alternative building materials, but his primary focus is mass timber. Michael has designed a number of CLT buildings, mostly in the residential sector, but also as rapid-built modular systems. And the title of Michael's talk will be Structural Engineering of CLT, South African Perspective. Then our third speaker is Michela Nocetti. Michela is from Italy. She's with the National Research Council of Italy, but she's also an extraordinary professor here at our department at Stellenbosch University. Michela has a PhD in wood science, and among other things, Michela has worked on the characterization of structural timber products, but also on the diagnosis and monitoring of wooden structures, and that also include mass timber structures. The title of Michela's talk will be Design the Durability of CLT Buildings, Risks and Solutions. Then finally, the closing remarks will be by Tafatswa Nyanzunda. Many of you will know Tafatswa. She's the Director of Forest-Based Industries at the Department of Trade, Industry and Competition. Tafatswa has several years of experience in agribusiness, enterprise management, policy and strategy development, and she has been an integral part, of course, in ensuring the implementation of the Forestry Master Plan. Okay, so Jamie, if you can kick off with your talk, please.
Okay. Hi, I'm Jamie Smiley from Xlam, South Africa. We are a manufacturer of cross-laminated timber in Cape Town. The talk that I want to give is just a basic overview of capacity in South Africa and the growth of the market, and then looking more into detail of some of development we've seen in So just basically the mass timber, there's a few important things to keep in mind. We are trying to do a sustainable product, so you need to keep an eye out for things like the FSC approvals, which shows you that the materials being used are from sustainable forestry, some type of certification, SATIS or SABS, to the standard in South Africa. There's a 8892, which is the standard for the manufacture of CLT specifically in South Africa. Fire safety is always an issue that comes up. I'm sure it'll be dealt with in another talk, but we have done fire safety studies. And then there's the carbon sequestration and the carbon storage of mass timber. We specifically deal with cross-laminated timber and to some extent glulam beams. But mass timber is a much larger range of products, and only a few of these are available in South Africa. The cross-lam is now available. Glulam has been for a long time in South Africa. Very few of these other products are available, and to what extent they will come into the country, we're not 100% sure. There is a good possibility for mass plywood panels, which, it's very few companies doing it internationally, but a very exciting product. Again, the standards that are in place, the fire test studies that have been done, and then as part of all of this, there's structural testing that is required. So you know that the products that you're buying in South Africa are to a standard, which is quite a big thing that we have a standard for a small country, a small producing country of mass timber, that we already have a standard in place, and it does allow us the opportunity to grow the market in Africa and even allow for export. So the key benefits that we know about mass timber: the speed, the carbon sequestration, reduction in labor costs, tight tolerances, improved safety, and the one that I would like to take a look at the moment is the off-site construction. So one of the key benefits with mass timber is this speed of construction and the ability to pre-plan a project to much finer details upfront. And this has quite a lot of benefits. One of the major benefits is that time and how that time saving affects the costs of a project. So timber, when you look at it from the outside, just as a comparison between kind of brick and timber, the timber always looks like it's a more expensive option. But if you take into account the entire development cost of these construction projects and the time saving that these type of mass timber projects allow for, time saving in on-site building, reduction in labor on site, the improved tolerances, which allows for better quality control. This starts reducing your project program. And then these cost controls can be much tighter as compared to traditional build. In South Africa, for the most part, we're seeing projects which are kind of panel projects. So we manufacture the CLT portion of the project, or the mass timber portion of the project, that gets taken to site, erected, and then all of the additional work is done on top of that. But we have seen a few projects coming on board, and this seems to be the more an interesting side with the off-site construction, is that these panels can now be developed into more complex items, such as full facades or even full building units. And this is what this diagram shows you. We're seeing these type of things where they're manufacturing semi-complete or complete units in a factory now, being able to put that on a truck or trailer and taking it to site. So here it shows you just kind of that type of breakdown. What we're normally doing is this first mass timber production part, where we're doing the manufacturing in-site and then the assembly off-site. So we're trying to reduce that time and do more of the stuff in factories. We have a industrial robot that we use for machining of this. This is a key component in the mass timber market, the ability to cut and these components to high tolerances to allow for easy on-site. So the example of a project that was done locally, and it was taken to a further stage. So all of those fins that you can see outside are timber fins, both outside and inside. It's a external grade timber on the outside, and then CLT panels on the inside. And were made completely off-site and then brought to site and assembled kind of as components, just lifted in. And that you can see the inside of it, the CLT portion of it. So it's a facade with the external grade timber on the outside. The smaller version, this is was done in Hout Bay by Morrico. This was built in a factory to a level where electrics and kind of your waterproofing and all of that stuff was done. Then was lifted into place. And then the final cladding and fit out was done on site to leave you with a product like that. So this is quite a popular product that we're seeing, is these type of small cabins for farms and for hotel type of accommodation. And then this is the more typical type of projects that we're working on. These are panel type of projects where we're taking the 3D model, or we're taking the drawings from the architects and engineers, turning it into a 3D model, a panelized format, and then the panels go to site and are assembled on site. And then the finishing work is done on top of that. So even with this type of construction, you're doing kind of panels and then supplying it to site, you can make huge savings in your program and in your time, which obviously can lead to cost savings. One of the issues that you've got to take into account is our cost of labor in South Africa. You know, in Europe, it makes sense for smaller type projects to be done in CLT because of your cost of labor for getting a bricklayer or somebody like that on site, where here it is a lot cheaper. So on a smaller scale, the mass timber and the CLT is kind of cost comparative. You know, we're not cheaper, we're not more expensive, but as soon as you start going on a larger scale, maybe 3 stories to 12 stories, then these type of benefits of your speed of construction and cost savings come into play quite a lot. And thank you. That's me, Jamie Smiley, and yeah, from XLAM South Africa.
Thank you, Jamie. Next up, we have Michael Kluis. Michael, are you ready?
Yeah, I'm just going to share my screen. Can you see my screen, Sam?
Yes, all good there. Thank you.
Good day, everyone. My name is Michael Kloos. I'm very excited to be presenting today. So I'm going to be talking about mass timber engineering and specifically from a South African perspective. So just a quick personal background. I'm a professional structural engineer, registered with EXA. I've got about 5 years working experience. So why did I transition into timber? Basically, I was very disillusioned with the status quo of the construction industry about 2.5 years ago. I found conventional building materials very unsustainable and uninspiring. We all know how big of a player the construction industry is. So I see timber as one of the solutions for a sustainable future. And furthermore, I see mass timber has great potential due to the fact that it can be rapidly scaled because we do have existing forestry industries in South Africa and quite a developed forestry industry. And then I also just fell in love with the material. So wood is an amazing material. It looks amazing. It feels good. You want to be in a timber building. And I think a lot of people can relate to this. And I found that in the industry as well, the people I've been working with are incredibly passionate about the material. And it's quite inspiring working with timber. And then finally, I'm very excited by the prospect of pushing boundaries in South Africa. So we're at the forefront of this new wave, and it's a very exciting place to be. So all the photos in the slideshow are from local South African projects that I've been involved in. So wood as a structural material, it's truly wonderful, but with great beauty comes great complexity. Timber is both an engineer's best dream and our worst nightmare. And why I say this is that timber has been optimally designed by nature to resist incredibly high loads and still remain light. You can imagine the wind forces, the compression forces on a tree are really significant. But it has a lot of structural challenges. So wood comes from the earth and the earth wants it back. This is basically through insect attack and fungal decay. So we really have to be very careful when we design with wood. All materials return to the earth eventually. For instance, steel rusts, but the rate at which timber can decay is quite impressive. And the other big challenge is the variability. So there's a plethora of factors that influence the strength and stiffness of timber. So there's a few here: species, age, the location of a plank within the tree. You've got your knots, you've got moisture content. There's 8 different strength values for timber as opposed to 1 or 2 for concrete and steel. So all of this makes it quite challenging for us as engineers because we like design values that are in a table, that we can work with safely. But timber, there's just a lot more variability. So how do we address these challenges? For the natural attack, we have to treat the timber. Basically, in all coastal municipalities, this is required by law. We have various treatments available to help with this. Inland areas, we don't need to treat, but we do, well, by law, we don't need to treat, but termites do pose a significant risk. And then in terms of fungal decay, the correct detailing is vital to keep the timber dry. So timber can get wet, but it doesn't like to stay wet. So you need to make sure that it can breathe properly. It's a living material, so you have to do the detailing correctly. In terms of the strength variability, we use what's called the 5th percentile for most of the structural strength properties. So what that means is that we have a huge variety in strength. You'll see on the right, there's a graph which shows the bending strength of SA pine. You'll see some planks have a bending strength of 5 MPa and some have a bending strength of 120 MPa. So this is huge variety. So we can't work with average values because that means half the planks are going to be less strong. So we work with the 5th percentile, which basically means that 5% is less strong and the other 95% is more strong. So this actually means that we're very conservative when it comes to the strength of timber. For stiffness, we're less conservative. We use the mean values, but the thinking here is that if a beam deflects a little bit too much, it's not really a problem. We're not putting people's lives at risk. And then furthermore, we do apply a material safety factor of 0.68. So this is how we as engineers kind of take this highly variable material and make safe buildings. So in terms of mass timber design, it introduces more complexity now. Glulam is more established and less challenging, but cross-laminating timber now adds another whole dimension because the grain is running in different directions. And the fact is that we have zero guidance in the SANS codes for structural design of CLT. And even in international codes, such as the Euro code and the American codes, it's only now starting to come into the codes. So I rely on handbooks such as the ones on the right, industry bodies such as Wood Solutions, and first principles to do my designs. So it's a relatively new structural material still in the bigger scheme of things. So the theories are still developing, the methodologies are still developing, which makes it challenging, but it also makes it quite exciting and does allow us a lot of design freedom, which I quite like. So where are we in South Africa with mass timber? We're making residential buildings, small-scale modular buildings, and non-structural elements such as facades and walls. You can see some examples on the left. Where we really want to be going is more mid-rise commercial. This is where mass timber has the greatest potential, in my opinion. So we're not quite there yet, but we are heading there. So in terms of what my structural design workflow is, basically we start at a concept design stage where I'm working very closely with an architect and the rest of the team. And we come up with designs, which then I take through structural analyses, and that's an iterative loop, which runs for some time. Once we've gotten to a point where we can move forward, we go to the detailed design phase. And this is where 3D modeling is very, very important. You can see here are two examples of buildings which I modeled in Revit, where every single panel has got a name, the dimensions are exact. And from this, I can generate accurate shop drawings myself, and also create assembly drawings for the assembler. And then finally, a very strong site presence from the engineer is very beneficial so that you can see what's working and what's not working. So in terms of shop drawings, the shop drawing is basically the drawing that a manufacturer uses to create the panel. So often this is created by manufacturers themselves, but I often do them myself because it just removes a kind of a broken telephone effect and gives me a lot of control in terms of ensuring that things are drawn correctly. Because if something is drawn incorrectly, it's not going to fit on site, and that throws out the whole kind of benefit of hassle-free construction. And then also on the right, you'll see connection details here. So this is basically showing the assembler exactly how to put the building together, which screw to use, where, what's the spacing, and structural details are very important to make a safe structure. So where I have found the complexity to lie within structural engineering of mass timber, especially, is in the detailing. So how things meet, where A meets B, how do we fit things together? There's an overwhelming number of different ways to detail timber buildings. There's hundreds of different types of screws, different plates. You can see some examples on the right there. So it can be quite overwhelming. And it takes time to understand these different methods and then to figure out how you're going to fit everything together. And it's not only on the structural level, it's also integration with the rest of the structure. So how do we do the cladding? How do we fit everything together from an architectural point of view as well? So all of this means that we're spending a lot more design time up front. And it does mean that we've got faster, hassle-free construction. But it also places, or the flip side of that is that it places a lot more pressure on us as the design team to make sure what we're doing is right. So it is a challenging place to be because you can't really hide behind, we'll figure it out on site. Your drawings have to be 100% correct. Otherwise, it's just simply not going to fit. So where I see the major challenges going forward is in the regulation on treatment of CLT. It's very unclear at the moment. It's not easy to pressure treat CLT. So we still need clarity there. There's a huge lack of skills and knowledge across the construction industry. This is including clients and building councils. We're generally very ill-equipped to deal with timber. I hardly, in my university degrees, we hardly even spoke about the material. And then arguably one of the largest challenges I see in the next few decades is a local supply of timber. So cross-laminated timber, or CLT stands for cross-laminated timber, but it also stands for consumes lots of timber. So if we want to drive large-scale adoption of CLT, and especially commercial buildings, we're really going to need a lot of timber. So we're either going to have to start planting more trees, or certain products, like we're going to have to transition from using trees for pulp and paper and other products and move them over into structural lumber. So finally, just some advice I could give to structural engineers who want to get involved or other professionals is to equip yourself with knowledge. There's a lot of knowledge on the internet, but you're also welcome to contact me. I can put you in the right direction. I found networking within the industry across the board, so from manufacturers to designers, very helpful, including academia. So you know what's going on in terms of research. Like I said, it's changing all the time. You have to embrace a highly collaborative work mindset. Because you're working so closely with the architect and assembler and manufacturer, you can't go into meetings with a kind of conflict mentality. You really have to be solutions-based and work together. And then I would recommend you spend as much time on site as possible and in the factories to understand the material. And then finally, you've got to take a bit of a leap of faith, because we are at the beginnings of something and we all believe in it, but we're not quite at large-scale adoption yet. So you've got to take that little bit of a jump. And then finally, I think especially for engineers, I can't stress enough the importance of spending time on site. If you've put together one of these buildings yourself, if you've rigged a crane to lift the panel, if you've put in the screws, if you've installed plates, it just massively increases your understanding of how these things work. And I found it very helpful to become a better engineer by actually putting these buildings together myself as well. And if you like me, you also enjoy it. It's fun. Cool. Thank you, everyone. And I look forward to any questions.
Thank you, Michael. Really fascinating and practical advice. Thank you. I'm going to get Michaela up on stage. Michaela, are you ready?
Hello, everybody. Yes, I am, but I can share because it's saying that all person can share the screen. Okay, thank you.
Here we go.
Yeah.
Buongiorno, and it's over to you.
So, good afternoon, everybody. In my presentation, I will speak of maybe an uncomfortable issue, that is the durability of the timber buildings. Okay, so we have said we all like wood, and of course we like to use wood in construction. Otherwise, we will not be here today, of course. And we are also right, because wood is really an extraordinary material, and in construction it is gaining more and more interest because of two main reasons. The first one is the rise of the sustainability matter, of course. The second reason is because of the technological developments, which wood means engineer products. As an example that was already mentioned, we have the glulam that's very known, and it led to overcome the shape and dimension limitation of the solid timber and solid construction. And of course, we have CLT, which changed completely the way of building with wood. But wood is always wood, and it has its own characteristics. Some are positive, of course, but some are less positive. Here you can see the pros and the cons of using wood in construction. Many of them have already been mentioned in the presentation before. I thank you for that. We know that timber is a renewable and recyclable material. It has a very low environmental impact. It's very efficient in terms of energy. It is light, and therefore it's easy to transport compared to other material. It has a high degree of prefabrication, and therefore it's easy and quick to assemble and dismantle if needed. It is called the dry construction and can be, of course, fully reversible. But we have seen wood is a biological material, therefore is high variable, and it is subjected to biotic and abiotic degradation. This means that we have to put a lot of attention during the design, but also during the assembling of the building and also the maintenance. Today I will focus mainly to the risk of water. Wood has a great affinity with water. This means that it absorbs and desorbs water to get in equilibrium with the external condition. But when the humidity is high or there is free water, it can reach high values of moisture content. And when this high moisture content will last for a while, let's say above 20-25% of moisture content of the timber, biological degradation due to fungi can start with a significant reduction of the mechanical properties of the material. And with time, the degradation can also compromise the stability and the static safety of the structure. So, when designing with wood, we like to say that we have to move forward from the durability of the material, the concept of the material, of the durability of the material, to the durability of the entire structure as a whole. Today I will present some issues that may occur in CLT structures. I hope to not scare you too much, but it's useful to know, to be aware to tackle them. So a frequent issue is the resin dump from the foundation. You can see here the water coming up. Here, I don't know if you can see my arrow, anyhow. Here you can see the water that's coming out, and so we did perform some verification on the panels. These are CLT panels. You see the moisture content measurement on the left and the drilling resistance verification on the right. You see from the profile down that it was a 3 layers panel and that it was still sound after the rising of the water. But in this case, it was not. And I can assure this that this was not the result of a fire. A solution could be to rise the panels so not to be in contact with the foundation, and also let the air to circulate. These are systems that are most of them patented, and there are some in the market, but are very effective. Another issue can be the possibility of atmospheric precipitation during the construction site. Of course, wood can get wet, but then it should be able to dry again. After the fall of several millimeters of rain, this structure was completely wet, so the moisture content of the wood was checked before the going on with the laying of the insulation and the enclosure. It is important that before cladding the panels, the wood is dry enough. This is very important. After that, the structure was covered to prevent the rain going again, and at the same time, the ventilation was guaranteed. It was also decided to step up with a permanent monitoring system of the moisture content of the panels. Several measurement points were placed, spread throughout the structure, mostly in points critical, let's say, for possible condensation or water infiltration. And the measurements were collected by data loggers, and software was set so to send an alarm when the high moisture content values were detected. This could be a very useful system, especially when the CLT is completely covered and no more visible or inspectable. Another issue could be an accidental spill of water in a building during its life. It's always possible. Think to the water that comes out, even for a days, from a broken pipe, for example. The monitoring of the moisture content here started to quantify the spread of the water, but you see here, during the first weeks, the survey observed a general increase of the moisture content of the panels. Why was that? It was because the sound-sorbing carpet was soaked with water and worked like a sponge to gradually release it. So only when we completely remove the floor, the composition of the floor, and the panels were again at air, then they had the possibility to dry again. Therefore, the teaching could be that a lighter and easily removable floor composition could be advisable, for example. And then very quickly, we have a few other issues. The flat roofs should be avoided. A slope, even small, even really small, is always better. Pitched or projecting roofs could be better. Of course, the insertion of rainwater down pipes inside the structure is also something questionable. We have seen that also, and we have seen this because outside they were not nice. All these elements may potentially let the humidity to accumulate and make more difficult to detect this phenomenon quickly. So my conclusion is water can be really a dangerous enemy for the timber construction. We have not to be scared, but we should keep it in mind. Think to the fire. We know that it is a risk, and we, let's say maybe you, because I'm not a structural engineer, design accordingly. So in the same way, the design of the durability of wooden buildings should become part of the current practice, like all the other phases of the design. And also it is advisable for the monitoring of the wooden buildings to become a consolidated practices in order to guarantee their structural efficiency and to guide the maintenance interventions, both extraordinary if needed or planned. So with this, I really thank you. And I'm here to answer your question if they are. Thank you.
Thank you, Michaela. I really appreciate your insight. Really great to have an international speaker with us. Just going to play a short video while we get our Q&A session ready.
The 19th century was the century of steel, and the 20th century was the century of concrete. We're moving into a wood century. The ability of wood to be carbon.
Becomes a big issue. That's a huge advantage.
Mass timber helps us set the stage in terms of the environmental ambitions of the project from a carbon standpoint, but then also extending that throughout the entire approach to the building and an energy efficient building, as well as a building that's healthy and sustainable in terms of its approachability and livability as well.
If someone's interested in using mass timber, I think they need to embrace the fact that they will be one of the pioneers at this point. You can be part of a revolution of building with a sustainable and renewable and natural resource that sequesters carbon rather than expels many times more carbon.
I'm very excited. I feel like we're just at the very beginning, and I think we're going to look back on this 5 years from now. I think we'll probably be laughing a little bit at the things we're doing, but I also feel like we don't have really a sense of how big this could be, and I think it'll just become part of the way we think about building, in the United States and internationally.
Apologies for the sound hiccup. I muted myself and then it muted the video. So I'm just going to bring up Brom. I'm going to bring up.
Thank you very much for all the speakers and your inputs. Extremely valuable. And maybe I think how we'll do the question session is I'll pose a few questions and then I'll open it to the floor, that we have some more questions from our participants, because they probably have also a lot of questions to ask. Michaela, maybe I'll start with you. The use of wood preservative as a solution for the durability of structures is obviously an option. I think there's probably two parts. One that you've already mentioned is the specific detailing to keep water out of building cavities, or that's really important. And then the other one is using different kinds of wood preservatives. Maybe you want to comment on wood preservatives. We're not going to dwell too much on this today, because our next session we will deal with that specifically. But maybe Michaela can set a bit of background to using of wood preservatives in timber.
Yeah, okay, thank you. I know that in South Africa this is a tricky matter, because there is some obligation by law. But what I can say is that, of course, the treatment with preservatives, it could help, but there are several points to keep in mind in this case. The first one is the sustainability matter. Of course, the products used should not be dangerous, not for humans, neither for the environment. Otherwise, we miss the sustainability of our constructions. Then there are also some technical issues. The bonding should be not affected by the treatments. And I know that Professor Brand Wessels did some work on this with a PhD student, so he has good news, I think. The treatment could not be necessary for the entirety of the panel or the structure, but can be also limited to the parts that are most at risk of degradation. But lastly, I want to stress that the effectiveness of the products decreases over time, and their use should not be a substitution for the correct design and maintenance of the structures.
Thank you. Thank you, Michaela. And maybe I'm going to push that same kind of question to Jamie and say, just ask, in your view, you have obviously experimented with different or tested different methods of with preservatives, and maybe just some general thoughts. We don't have to go into the detail now.
Yeah, the wood preservative is quite a big story with the timber and mass timber. Obviously, the panels are very big and difficult to treat once they have been manufactured. I know that Bruce and Billy next session are going to be dealing with it more in depth. CCA is the most common one that's used in South Africa. It's not feasible for mass timber. It's water-based, so it puts too much water into the wood before you're trying to laminate it. And yeah, copper, chrome, arsenic, and I think it's probably as bad as it sounds. So, yeah, it is something that we need to take into account, and possible strong surface treatments and then maintenance is probably going to be the major issue.
Jamie.
If I can just weigh in my 2 cents there. Yeah, this is a very hot topic at the moment. I did name it as one of the challenges, because the regulations are a little bit unclear. It's quite challenging right now how we deal with treatment of CLT specifically. But yeah, I agree with Michaela that the detailing, keeping the timber dry is the biggest step to take. No matter, even if you put an H2CCA on your wood, and if it starts getting wet and soggy, it will still decay. So you can't rely on it too much. And in terms of toxicity, there's a lot of potential in boron-based treatments, because it's not very toxic. It actually has very low mammalian toxicity. It's basically just a salt, but the bugs don't like it that much. And I think in terms of insects, that's something quite specific to the coastal zones of South Africa. So that's not to do with detailing. It's difficult to detail borers. They're going to get in there somehow. So it is a very challenging challenging topic right now. But I think I've been in lots of discussions with Bruce on this, and I think we're moving forward. Yeah.
Thanks, Michael. In our next session, we will deal specifically with this, with preservatives and treatment of timber. Michaela, another question maybe is, you obviously research buildings, and you have shown some examples where you do some permanent monitoring of timber buildings. Is that quite expensive to have these sort of permanent monitoring systems put in a building, or what's the challenge in that? Sorry, Michaela, you're on mute.
Okay. Yeah, I was saying that the permanent monitoring of the moisture content, of course, is very important, especially when the CLT panels are, as I said, completely covered and they cannot be inspected, or they are not visible. So this could be an help. Of course, again, the design is also in this case very important, because we have to know where to put the measuring stations inside the buildings. But yes, in Italy, for example, is growing attention. There are also some protocols for this monitoring inside the structures. And as an example, I can just say they are not so costly. For example, we have the experience of a 2 floors building of more or less 2,000 square meters. And in that case, the cost was of about 8,000, 10,000 euros. So it can be, of course, a very useful instrument to prevent bad events, of course.
Thank you, Michaela. Michael, maybe you've alluded to your process. I think maybe explain a bit more. I think what's imperative in designing timber buildings is obviously the connection of the architect with the engineer, and it's a very close collaborative process. And then when the manufacturer gets involved, it's actually a sort of 3-tiered, or it's a triad of expertise that you need to put it together. In terms of your software interface is also very important between your architect, your manufacturer, and yourself. Maybe you can elaborate a bit more on that process and how important that is.
Yeah, it's a great question. I think it's been, the collaboration between the architect and engineer in the beginning phases is extremely important. And like I said, you got to go into it with a solutions mindset. I actually enjoy it quite a lot, and like I said, everyone who's doing this at the moment really is having a lot of fun doing it. So we enjoy collaborating. I think if you didn't, you'd really struggle to make a success out of a timber building. That's the reality, I think. And then the assembler as well, so the contractor, basically, because everything feeds together, So when you the more you involve people, obviously too many cooks can also spoil the broth. But basically, if you take into account the challenges of the other party, you can create a much better structure for everyone. In terms of software, we're not really at the stage yet where we're doing BIM, where we're working on the same models, things like that. That's obviously the dream. But where I work at the moment is with Revit, and then typically I will make a Revit model, and then with the architect we'll exchange our export to CAD, and then the architect will do their detailing on top of the export, my exports, because ultimately my model and my shop drawings will be what is in reality, right? So it makes sense to base then the next layer, the architectural layer, on the shop drawing layer, basically, as opposed to another model which might not match what is then actually on site. Yeah, did I answer? Is there anything else? Did I answer the question, Bram?
Yeah, no, I think it's a totally different working method. Our collaboration with the engineers, it's almost like the model becomes the building, and
Yeah.
everything is resolved on already on a BIM level and in the computer, so that you can move that model then to the manufacturer. And
Yeah,
maybe Jamie
exactly. Yeah.
can comment a bit on that when he receives the model from yourself or from the architect. I think that's also a very important process. Maybe Jamie can elaborate on that.
Yeah, just quickly, the one thing, there's two different ways. Like either Jamie would receive the model, and then they would generate their shop drawings. I took it a step further. I actually created my own shop drawings. It was it was an experiment actually to see how it would work out, and I found it to work out quite well. Just because otherwise, what needs to happen is, I need to check shop drawings, and then that loop of continuously reviewing drawings can become quite onerous, on all the team. So on the other hand, I'm taking more responsibility in a way, because I'm making the shop drawings and I'm taking responsibility for that. At the same time, then I just have that greater control. But there's different ways to swing it. I think the other option is that, a model just gets sent across, and then the manufacturer can break it up into panels and suggest connection details and all those things.
Jamie, some comments?
Yeah, the ideal is that the engineers will be able to supply us as the manufacturer just with a full set of drawings, that we're just doing the manufacturing work. We've taken on quite a bit of the kind of design detailing because it's a new product to South Africa and somebody had to do it. We do have our own software that we do import the BIM type of models to, and that's specifically for the cutting. So we want to use exactly what has been sent to us as a 3D model for the cutting and detailing of the panels.
Thank you, Jamie. Maybe we must, Sam, we must allow some questions from the floor.
I'm just aware of time, Bram. There is an auto end on the session, and I'm sweating a little bit, and I'd like to Fadsma to speak. Joy, we do see your question, and if we don't get a chance to answer it, we will definitely email you the answer if that's okay with you. So I'd like to maybe give to Fadsma the opportunity to do the closing remarks, and if we by luck and magic we have another minute or two, we can answer that question.
Okay. Thank you very much. I think we're beginning to make progress in as far as trying to create awareness of mass timber as well as CLT in construction. So I like the work that Jamie has shown of that local example of Deloitte offices in Cape Town. I like the statistics also that has been shown by Michael in terms of how do we calculate backwards into the forest. I think what we then need to put there is how long are we growing this timber in the 12 hectares in order for us to be able to build a 240 square meter space or house. And also, in terms of the regulation on mass timber treatment, is the conversation that we will be having in our next webinar. We are looking at timber treatment, and definitely we will try to see if we can get somebody to talk on the CLT treatment. So I think with that, and I like what the issues that Michaela has also pointed out, so that at the back of the mind, whilst we're doing this, we know what are the disadvantages and how do we overcome them. So that is a positive. So quickly, I would just like to give a vote of thanks to our sponsors, Sawmilling SA. Roy there, thank you very much for affording us this opportunity. I would like to also say to University of Stellenbosch, University of Pretoria, and Nelson Mandela, you have been able to provide the content and as well as the contacts for this work to progress. So slowly we are making progress. This is a long journey, but we've started. So to all our speakers, I must mention our deep sense of appreciation to Michaela all the way from Italy, and to Michael from the University of Stellenbosch. Much appreciated. And further, we're very grateful to Jamie to sharing your knowledge as a private sector where you don't usually get that, but you've come on board and you are willing to work with us. And to Prof. Brad and Bram, I think your faces are the brand for this work. You have really inspired us, and you have put in a lot of time in this work that we are doing. So to all our audience that have logged in on AirMet and YouTube, thank you very much. We wouldn't have had this, and we wouldn't have gone ahead if nobody logged in. So we look forward to seeing you again in the next few months, where we will have our third webinar in a series of 6 webinars that we have planned to do. You are welcome to stay online, and it looks like we don't have much time, but let's network. Thank you very much.